Two researchers during games night. This is their second favorite thing.
My dad works with lasers.
I think it's pretty cool what he does with all those lasers. Science and the instinct to play are what brought Stephan Barcikowski and Bilal Gökce together.
It's all about heroes, just as in research.
It's a kick, just as in research. After all, in research, you also have to read up and try to understand the subject.
Physicist meets nanoscientist. Bilal Gökce made his habilitation with Stephan Barcikowski.
What I find exciting is that you can explain absolutely everything by applying the basic laws of physics.
As a chemist, I can't just let a comment like that go, that physics can explain everything. If you know a little physics and something about materials and then put the two together, actually, while I'm talking, I suddenly realized just how strong we are as a team.
University of Duisburg-Essen, Department of Technical Chemistry. It's all about thinking big, even about the tiniest of particles. It has long been possible to synthesize nanoparticles. However, the conventional processes are complex when a high level of purity is required. The solution? Laser-based technology.
By pulsing the laser beam, it can ablate a solid. This is nothing new. It can drill holes and cut. Our idea now is to cover it in liquid. At first, this is quite surprising. After all, the laser first has to get through it. Then the laser ablates the material. The liquid now does something very important. It collects the ablation products, or the material that is removed. And this material has unique properties that are impossible to achieve by conventional synthesis processes.
The big challenge was how to increase productivity. A cavitation bubble forms when a laser beam is focused into a liquid, meaning a lot of parameters have to be brought into sync. The professor and his team succeeded.
We then had our laser system designed and set up around this cavitation bubble. This makes it possible to adjust the pulse rate or speed of the laser, depending on the cavitation bubble, which increases productivity by up to 2 orders of magnitude.
To be precise, an increase to several grams per hour.
We were definitely on pins and needles when we started up the equipment for the first time.
Will it work or not? And yes, it pretty much worked at the first go.
And right away I knew, this is it.
We did it.
An unbeatable advantage of the new technology, the nanoparticles are of the highest purity. The chemical synthesis of nanoparticles works very well, but has several disadvantages. For one, it requires large amounts of energy. Secondly, it is usually carried out in a solvent. And thirdly, and this is the decisive factor for catalysis, it always requires the use of stabilizers. This means that the nanoparticles are not pure, as they would be using the laser method.
As an example, if we use this method to produce colloidal iridium, we use nothing other than iridium and water, and we can even recover the water.
The chemical industry has been waiting for this for a long time. The innovation harbors gigantic potential worldwide, also for medical technology and especially for additives production, in which nanoparticles enhance material properties.
For example, you would be able to generate an object such as this one. This is a component that demonstrates the possibilities of 3D printing, the complex geometries that can be produced using this process.
If you look to the future at power generation, for example, fusion power plants, if we have materials that are better able to withstand high temperatures, then we've already achieved a great deal. And the success story of the inventors continues, thanks to the spin-off Auto Pro Nano.
With this spin-off, we want to market laser ablation technology for the generation of nanoparticles and make it available to all. We have packed the technology into a machine that is simple to operate, as easy to operate as the coffee maker at the office. Only, instead of ending up with cappuccino or latte macchiato, you get colloidal gold, silver or platinum.
Two that have found each other. Hopefully, this is only the beginning.
Nothing beats being a researcher at a university.
Essentially, you're playing. You have a play area and you are allowed to play in the laboratory. You can do whatever you please and get paid for it.
How enviable. That leaves nothing to be desired, except perhaps winning the board game.